Microsoft has made a great commitment about HPC Server,
Yeah.
as you explained, and there is a new technology called Dryad, initially developed by Microsoft Research.
Yes.
Can you explain what the motivation to make Dryad and HPC Server?
Yeah, absolutely. So Windows HPC Server, for those that don't know, is about bringing the power of high-performance computing to the Windows ecosystem and really making that high-performance computing power accessible, and to create a consistent stack that where everything, like you would expect with a Microsoft product, you get this high-performance computing product. It's accessible, it all works together, the management tools all work with the management tools I was already using, the cluster already integrates with my Active Directory, it fits really well into my IT infrastructure and I can be immediately productive. At the same time, it supports all the standards that I would need to support in terms of high performance computing. So if I have applications that require MPI, I have good MPI support. If I want to do SOA, I have good SOA support. If I want to do high performance interconnects, InfiniBand, what have you, all that support's built into the operating system. So that's the idea behind HPC Server. In terms of where we are on our journey in HPC, we've shipped 3 versions now,
yeah,
and some service packs along the way as well.
We have the currently service pack 1.
Right, we're at the 3rd version of HPC Server, which is Service Pack and Service Pack 1. Working on Service Pack 2 right now. And in terms of performance, we couldn't be happier. We started out, as you might imagine, weren't that competitive in terms of performance relative to where, for example, the Linux world was in terms of HPC performance. But if you look today, we've learned a lot in the market. And our best performing supercomputer on Windows now clocks in at over a petaflop in performance. So that would put it, if you were gauging that in terms of the top 500 ranking, that would put us somewhere around number 5, number 6, if we were putting that on par with the other machines that were on the top 500 list. So the joke I always tell people is, it's like, yes, the operating system that brought you Clippy can also bring you a petaflop of computing performance across hundreds of nodes and thousands of cores and multiple GPUs per core, or per node rather. So that's where we are on HPC. In terms of Dryad, so Dryad's a really interesting technology. Came out of MSR. There are a couple different ways to think about Dryad. At its, I guess at the highest level, you can think about it as a really, really useful way to solve big data problems using a MapReduce style of model. And it's a little bit selling it short just to compare it to MapReduce or Hadoop or some of these existing technologies, because that's really a subset of the technology's capability. The more nerdy way to think about Dryad is it's a runtime, and then we build a link programming model on that runtime. But this runtime knows how to plan and execute a massive directed acyclic graph of what needs to happen in terms of compute and data manipulation to work at large scale, putting compute to where the data is on my network, on my cluster, or maybe in the cloud on Azure, and then successfully going down this graph until we can compute an answer for somebody. So if you can imagine a large link query over some unstructured data, like say web server logs, kind of a canonical example. I've got a whole farm of web servers. I want to do some analytics on those web servers. What's the easiest way to do that? One way would be to use a technology like Dryad to go farm all of those logs for specific data, and use Dryad's ability to run on a DAG to efficiently use my computation horsepower that's available to me on the cluster, to also move my compute problems to where my data is, which is the way you have to handle big data. You can't go moving data around on the network. And then also to do so with some fault resiliency. So as we're computing this graph, we find that at large scale, it's a fact of life that stuff goes down, like hardware fails. Hardware's not built to last forever. There's some mean time between failure, and something's going to fail. And when it does, the Dryad runtime is smart enough to go, this node failed. Let me back up to the nodes that fed this particular node, recompute, and then let me fail over to some node that has that's still up, and then continue with the computation. That kind of functionality is really useful at large scale, where if you have a job across hundreds of servers that lasts hours or days, the last thing you want to do is like go, it died, let's restart it. You want to make sure that that's kind of a self-healing process, and that's something that Dryad gives you. So really it's about large-scale data analytics, but doing so not in the classic BI or structured SQL sense, but more in terms of working with unstructured data, which is what we're finding our customers in the technical computing world are mainly dealing with. Less structured data, not totally unstructured, but less structured data, and certainly not necessarily relational data, but stuff that's in files that they need to go farm.
And you plan to provide new debugger window to see DIAG or?
Yeah, that's a great question. It's in our strategy. So the question is, when can we get all this stuff out? There's an academic release of Dryad on the Microsoft Research webpage. People can go get it now. We also have a commercial version of Dryad that works on Windows HPC Server, SP1. So 2008, R2, SP1. We'll work on getting these names shorter, but right now they're still pretty long. V3, SP1. And so we have this in beta. Folks can use this today in beta. And then for our SP2 release, which is the release we're working on right now, we will have a commercial released version of Dryad. So it's going to be available shortly. In final RTM quality commercial form. What we'll have at that point is we'll have the Dryad runtime that runs on Windows HPC clusters. We'll have the Dryad Link programming model, which gives people the ability to use Link to solve these big scale data problems. And then in terms of Visual Studio tooling, we probably won't have any additional Visual Studio tooling available in the initial release. But on the list is a host of things that we'd like to do in Visual Studio to make it really easy for people to debug and do performance analysis of these applications, because they typically have different characteristics in terms of the performance problems. With these large-scale graph execution systems, the performance problems are usually the imbalanced node or the imbalanced set of nodes where you've partitioned your data a certain way across your cluster, and for some reason one partition one partition of the data goes outsized, so you have one thing that's taking a really long time that's slowing down the entire thing. You'd like tools that help you identify those hot spots. And so that's definitely going to be a design focus for us.
Yeah.
On the debugging front, you would like to watch this graph execute, and that's something we're thinking about. How would we do that? But at the very least, you'd like to be able to do things like when something goes wrong, you'd like to be able to go out to that compute node maybe, figure out what's going wrong. And the other thing we're trying to figure out is the debugging story in Azure is different than the debugging story on Windows servers.
Sure.
They're different operating systems, basically. So we're trying to figure out, okay, so what's the right story for on-premise clusters? What's the right story for Azure? We don't quite have that nailed down yet, but that's another thing that we're thinking about is how do I want to behave differently based on whether I'm on a cluster of servers or whether I'm out in the cloud.
Yeah, but for a developer currently programming Link or sometime in P-Link, Link on Dryad is quite similar.
Yeah, that's right. Yeah, that's one of the goals and why we were really excited about this project. Supercomputing is hard. Even if you take tools like Hadoop or Pig or something that's built on top of these kind of frameworks, there's a learning curve. People have to learn to do some new things. We were really excited about the opportunity to use Link with Dryad because it does two, coming in from two directions. So from one direction, you have these .NET developers that know how to do Link and know how to do P-Link, but they're probably new to this large-scale big data problem. But it's probably a problem that their companies are starting to face. Like, wow, I've got these things, these problems, these data sets, they no longer fit on one machine. How can I efficiently go solve them? And so we can bring those .NET developers and say, well, just take the skills you have and you're good to go. Like, you got to learn a few new things about data management and maybe work more closely with IT or pick up some IT skills in terms of learning how to manage these high performance systems. Or in the future, just go to Azure and you don't necessarily have to learn how to do that on-premise management. From the other direction, you have more of the people that come from that big data, big compute world. And what's exciting there is that we're offering them a set of tools that's way simpler, both simpler than many of the tools they've used in the past, but also an industrial scale, really proven tool set in Visual Studio that they can use to start to solve these problems. So it's all these things just kind of work together to make the technology more accessible to a broader set of people. Even on the hardware front, I think we're doing interesting things in terms of accessibility, because the cluster that you would run Dryad jobs on is the same Windows HPC cluster that you run your MPI jobs on or your SOA jobs. So we're trying to work with customers to make sure we drive down their total cost of owning these things. You don't need to have a special cluster with a special file system that you use only for this kind of job. You have a very general purpose cluster that still, in terms of performance, is extremely competitive. But it's not. You don't have to make it dedicated. It doesn't just do one thing. You can have it run lots of different things, kind of increase the utility and utilization of the whole thing.
Okay.